Everybody, welcome to today's webinar. It's called Deploying CloudScale Analytics for AI and Machine Learning to Drive 5G Network Automation. And it's brought to you by Guavus in partnership with AWS and STL partners. So we're pleased that all of you could join us today. The speakers today, we've got a fairly full panel. We have two gentlemen from AWS who are heavily involved in the analytics work at AWS in the telco segment of the market. That's Guy Benbrook and Naresh Rao. We have Tilly Gilbert, who's an analyst at STL Partners. And she's going to join us to give us some insight from an analyst perspective. And we have the head of 5G strategy and product management at Guavus, Andrew Colby. So we have a fairly diverse group of speakers here. And I'd like to just go around quickly with the speakers and just have them, Andrew, just say hi so everybody knows who you are. And
hello, welcome, and thanks for attending this webinar.
Yeah, and Guy, you just wave so people know there.
Hi,
Naresh.
Hello, everyone. Please welcome to this webinar.
Hi, guys.
Good. All right, so now we know who everyone is here. We'll jump in here. So just a quick agenda. We're going to have this kicked off by Tilly. She's going to give us the, like I said, the analyst perspective on what's happening with 5G and analytics. I'm going to give a very brief introduction to this new 3GPP standard called Network Data Analytics, or NWDAF. And then we're going to dive into a roundtable discussion with all of the speakers, kind of exploring this topic from a number of different angles. Hopefully, we'll have time for Q&A at the end. Hoping we're shooting for maybe about 10 minutes for Q&A. So if you do have any questions as we move along here, just enter them through the questions tab in the GoToWebinar control panel, and we'll keep track of those. And we'll probably tackle those towards the end. So with that, I think what I'm going to do is pass the baton here to Tilly and let her talk through her presentation.
Thanks, Stephen. So.
And also, I'm going to go on mute and shut off my video.
Great, thanks so much, Stephen. Before you do, just to check, you can see my screen? Great. So what I'm going to do is just run through in 10 minutes or so a little bit about what we're seeing from the industry in terms of 5G and network analytics. And the first thing just to briefly touch upon and point out is sort of why are we talking about this today? Why is this such a timely topic area to be discussing? And I think that we can look at this both from the short-term priorities we're seeing from operators at the moment, as well as from some larger, more macro trends within the industry. So the chart I'm showing at the moment is focused a little bit more on the short term. So how have we seen operators' priorities change during the COVID-19 pandemic? And we at STL did a large survey back in May, to ask operators about how things had shifted and what was changing because of the pandemic. And what you can see here is in terms of technology domains that operators were evaluating and looking to pursue, automation clearly came out as that one technology domain where the majority of respondents replied that they were going to accelerate their efforts around automation due to some of the outcomes of the COVID-19 pandemic. So you can see there in the red and the orange, the bars showing that the majority were seeing that as something that needed to be pursued more rapidly because of COVID-19. You can also see that operators were in general looking to accelerate their efforts around AI and analytics as well. So on the short term, we've heard from operators that this is a priority for them. This is something that COVID-19 has demonstrated the importance of it to their operating model. But we also know that there are some big macro trends within the industry that are fueling interest as well. So 5G rollout continues and picking up pace. And more importantly, perhaps we're seeing some evidence from the early movers of the impact of 5G rollout, which is probably fueling others in the industry. We're seeing continued evidence of impact of AI and analytics across 4G and legacy networks, again, bringing this topic to the fore. We're seeing interesting announcements and trends around the increasing cloudification of networks, including some interesting announcements from specific operators like Dish around their use of public cloud in order to do this. And we're seeing, real acceleration of efforts around Open RAN as well, and kind of virtualization across the spectrum from access to core for operators. So I think both on the short term and the macro industry trends, we're seeing real kind of acceleration of efforts around AI and automation. And I don't want to labor this point, but we at STL, and I think it's close to some of the thinking that Guavus had, just want to bear in mind that with a 4G world, AI and automation and running your networks was primarily an overlay function for the network itself. And we liken this to a sort of a jumbo jet where you use automation and data analytics in order to help support you, but ultimately it is the pilot who's in charge of landing the plane. In comparison, when we think about 5G, we think this is much closer to a fighter jet analogy. And in a fighter jet, it's actually impossible for a human to fly a fighter jet themselves. The controls are too fine-tuned, and a human would really struggle. So that is, entirely reliant upon automation in order to function. And it cannot be an overlay. It must be something that's baked into the systems that work. And that's the kind of shift that I think we're expecting to see as we think and talk about automation in a 5G world rather than a 4G one. So it's exciting, but it doesn't come without its challenges. And we've been speaking to operators a lot about what this brings in terms of cultural and technological challenges. And the thing that we've learned from operators is that the technology is difficult, and they are trying to grapple with how they can implement use cases, particularly within the networks, which are highly difficult from a data perspective, highly difficult from an implementation perspective, highly difficult from a scale perspective. But what operators primarily told us is that the technology is a challenge, yes, but it's a challenge that they can see a route to solving. It's something where they think they have some of the skills and the abilities to work with their partners in order to solve some of those hurdles around the technology. What we did hear instead, though, where we heard that operators were much less clear about their route to solving the problem, was when we were talking to them about recruiting and training the people that are needed in order to run AI analytics at that cloud scale. And here, there's, I think, a lot less clarity within the industry around how operators are going to recruit those people that they need, hold on to them once they've been recruited, and ensure that they're recruiting people that can also bring that kind of telco expertise, as well as some of the data analytics and AI expertise that they need. So it's worth bearing in mind that the most operators are trying to handle both or challenges that fall into both of these buckets, but perhaps some of that cultural and people side of things being more difficult for them than the technology too. And I don't have time to go into a lot of detail, but maybe just to touch upon two challenges that I've heard from operators, one that's focused a little bit more on the culture and the people side of things, and one which is a little bit more technology focused, and is what I'll do in the final kind of few minutes of my opening presentation. So on the people side of things, a question that we've been asked quite a lot, and I think many within the industry are trying to handle, is how do I ensure that if I get to a point of closed loop within my network, often seen as sort of the nirvana for operators, how do I make sure that my team, that my network engineers trust this system and trust the recommendations that are coming out of it? That's the first question and challenge. The second one is a little bit more on the technology side, and it's how do I handle AI and automation when I'm thinking about networks in a different way, when I'm thinking about running them perhaps as a best-in-breed effort, where I'm not primarily working with just one or two vendors, but instead I'm bringing a lot more parties to the table that need to integrate with each other in order to enable me to run my network successfully. Those are the two questions, two challenges that operators have put to us recently. And to start with that first one, how do I ensure my team has trust in closed loop systems? I think what we say is that there has to be checkpoints, checks and balances at every point in the kind of the closed loop system. And this probably needs to be implemented on a sort of a step-by-step basis. So if we walk through briefly what happens within kind of implementing a self-healing network, we're going to start off with some real-time network telemetry data. And in a self-healing, or a self-optimizing network, the goal is to feed that data into a recommendation engine. That recommendation engine will go through a policy engine that may be powered by machine learning, which can help to identify potential issues, recommend the next best action based on the policies and the playbooks that have set by the network operator. And that can then deliver those actionable insights, which are ideally also implemented in an automated fashion, so without human involvement. If you do all of this in real time, then you start to get something which looks like the self-healing network that everyone is talking about. Complementing this, alongside this, there's also the outcomes or the event-based data and a whole host of other data on network ops, which is being fed back into a centralized data lake. And this can be analyzed retrospectively to develop better insights on how to improve the management of network functions, with the aim of updating those policy engines to meet the change in usage patterns or the change of needs within the network. What we think, in order to make sure that you have trust in this system, is that at each point along the way, there has to be a transparency and an explainability to your existing network team. So they have to be able to understand why the recommendation engine recommends what it does, particularly if that's different to what they may have done in their day-to-day practices before. They have to understand how the policy engine ensures that policies are met. They have to understand why an action or an insight has been suggested before it's implemented in the network. And they have to have faith that the policy engine is being successfully updated at the end of it. So we think that's kind of the key way to pull apart how you can start to build trust in a self-healing network, is to ensure that at each of these steps, where needed, there is the transparency and the explainability to be able to communicate back to networking teams about what it is that's taken place and why. The other side of things is to think a little bit more about the technology. As I said, the other key sort of area that I pulled out that I was hearing from operators was a challenge or an industry question around 5G and AI and automation, is around how you handle a new best-in-breed environment. We're hearing a lot of excitement around Open RAN and around other efforts to open up the network to new DIY best-of-breed vendors. But this does not come without its challenges. And within Open RAN, we've seen architectures which look a little bit like the one on the left, where you have one vendor running the kit at the base station and the other running the virtual baseband unit. And we're also seeing other architectures where we're actually seeing a centralization of CUs or a pooling of CUs with different vendors running various parts of that. And the major challenge around all of this is probably around standardization. And this, of course, becomes particularly important where you no longer have networks dominated by kits from one or two main nets. And what I'm showing here is the different architectures that Open RAN, could offer for operators. I think there's two main things just to think about before I hand back to Stephen. The first is, it isn't yet clear just how flexible and DIY operators are likely to go. There will be some, probably those that are the real early mover Open RAN converts, some of the big tier ones, who want to exercise true flexibility within their vendors. But there will be many, I think, who will start to follow a few blueprints that are set out by the industry, where there sort of is evidence of a successful deployment, and they'll follow that. So we talk about this world of open interfaces, truly best of breed scenarios, but I think it is worth reflecting back on just how much we expect most operators to go down that route. But the other key point that I wanted to just talk about a little bit was around standardization and interoperability, and how it's sort of key to making any of this work. And when I say making this work, that means more than just standing up the network, rolling out 5G. It's about the ongoing management and performance of the network, and those day two operations. And without one neck to choke or one line of clear responsibility to a primary vendor or one or two primary vendors, telcos need that reassurance that this really is a scalable and high performance solution. And I think one of the ways that they may look to kind of get that reassurance is by understanding how some sort of standardization on the analytics side and on the interface side to deliver for them what they think can be achieved with Open RAN and other best-of-breed efforts within the network. That was very quick little snapshot of what we've been hearing from the community that we've been speaking to, and I'm interested to hear the views of the rest of the panel as we go through on some of these topics as well.
All right, well, thank you, Tilly. That's a great overview. I think people should be able to see the slides again here. So I'm going to back up. That's the wrong slide. So just very quickly before we kind of jump into the discussion, and panelists, just come back online with your audio and your video if you could. One of the big differences in 5G compared to 4G is in 5G, the 3GPP has standardized a network data analytics function called NWDAF, and this is a function that's going to reside in the 5G core along with other network functions and application functions. It's part of the 5G service-based architecture. There are detailed specifications for this. I would encourage anybody who's interested in coming up to speed on this to look at the information on the Guavus website because there's a good set of resources there, but also you can just go straight to the source and look at the 3GPP documentation yourself. That might be a little bit daunting, but nonetheless educational. So this is one of the things that's different about 5G. I think there's a recognition that analytics is so critical to the operation of the network that they want to standardize how analytics is going to function in 5G. And Andrew's going to talk about that a little bit more. And the other thing I'll point out is that from a use case perspective, there's nothing exotic going on with NWDAF. There's actually going to be a wide range of use cases envisioned for NWDAF in the various 3GPP releases. But, it starts with monitoring the network, what's going on with performance and load and congestion and detecting anomalies and making sure, QoS is sustainable for users and looking at what's going on with device behavior, whether that's mobility or communication patterns or abnormal usage that you'd like to detect. And then kind of rolling up that information to essentially a view of service experience and developing metrics that monitor service experience, and not just for human users. I mean, 5G is going to be different because I think we're going to see a lot of machines relying on the network, and we're going to need to quantify service experience, on behalf of the machines that might not be in a position to speak up like a human would. So, NWDAF, it's a new thing from a standardization perspective, but the uses for it are going to be all the things that any mobile network operator is going to care about. So let me kick off the panel discussion just by setting up a topic here for us to discuss briefly, which is how will 5G impact MNOs and their enterprise customers? Not necessarily the consumer side of the market, but what's going to happen in the enterprise domain in terms of the services that are going to be offered and what that places on the MNO in terms of requirements for enterprise that's going to be utilizing those services. That's a little different than just, a consumer user using a phone to, make phone calls, send messages, or stream video or access the web. This is going to be stuff that, should become mission critical in many perspectives. So I'm going to go around the table. Maybe Tilly, you could take a shot at this briefly and then pass the baton to Naresh and Andrew.
Sure, yeah. I mean, the first part of the question, how's it going to impact MNOs? I think you've already started to indicate some of the potential ways that it will see operators need to upskill and change the way they work and change the technology they use. I guess it's also true that 5G is only going to impact MNOs with their enterprise play if they make some significant changes to the way that they engage with new ecosystems, to the relationships that they have with their enterprise customers, and that they're going to need to deepen and strengthen those, probably make some difficult choices about a few verticals to focus on in particular, if they're going to see anything too different with 5G to what they've seen with 4G and other forms of technology. On the enterprise side, I think enterprises don't really mind what kind of technology is being used. It could be 4G, it could be 5G, it could be Wi-Fi, so long as it's delivering them some business benefits. So if 5G means that MNOs can open up new use cases, or even if they can deliver old use cases with a significantly higher user experience or significantly higher flexibility, then that's where 5G gets really interesting from the enterprise perspective.
Andrew, want to add to that?
Sure, and I think I agree with Tilly that there's going to be some significant impact on the mobile operators. I mean, one of the big differences, and Stephen kind of alluded to this, is with the network data analytics function, analytics is baked into the network signaling. The other network functions that set up calls and data sessions and devices have connections, have calls into the network data analytics function and utilize that information in the decision making. So that's a huge difference, as Tilly said in her opening remarks, going from analytics as an overlay function around the network to analytics baked into the network itself, and from there the automation can be baked into it. The other dimension of it is how this analytics can impact the relationship between the mobile operators and their enterprise customers. It affords an opportunity for the operators to be more than just a communication pipe provider, but now become a part of the digital supply chain or digital ecosystem of their enterprise customers, and interact with them not only at the application level where they're communicating with the devices, but also below that, where we're communicating or they're communicating with the enterprise or with the application management function about the communication with the device, or where the device is in the network, or its state, or other relevant information. And this allows the enterprise to utilize the communication service in vastly new ways, and will allow a much more dynamic relationship between the mobile operator and the enterprise. And everyone's going to be, that'll be an adjustment for everyone, but it's a super opportunity.
Naresh, would you add anything to what Tilly and Andrew said?
Yeah, I think I concur both, Tilly and Andrew, like most of their points. And one of the main important thing that I would like to highlight is, the transformation from being just a connectivity provider for an operator to digital service provider, it actually accelerates them, because they are able to utilize the fully virtualized stack, bring new services as soon as possible. Today, one of the paramount of a problem for most of the operators is like they launch services, but the consumption from an enterprise, due to the various reasons, like there has been a lot of delay. So, but now in actually, by reducing the cost, they can bring new services as soon as possible to the enterprise. That's the biggest plus. And they see definitely a monetization options, not just being a connectivity provider. So this is one of the huge benefit for the operator and as well as an enterprise.
All right, let's move on to our next topic here. And Tilly essentially touched on this in her introduction, that the biggest difference I think between 4G networks and 5G networks is when we did analytics in a 4G network, it was an overlay model, and we were largely feeding information that was going to be used by human operators of the network. And in contrast, in 5G, as Andrew explained, it becomes integral to the operation of the network and essentially kind of a cog in the machine for 5G network automation. And I think, Naresh, maybe I'll let you talk a little bit about that. You don't necessarily have to talk to all the details in this slide here, but maybe just elaborate on that a bit.
Yeah, sure. I think, at least what we have sensed, by a lot of interaction with our big telcos, that the network optimization, especially in 4G, and more of an analytics-driven optimization was always an afterthought. Like it runs in parallel. Okay, there is one connectivity model that you basically, your main job is to provide the connectivity, the 4G LTE connectivity. Another one is there is always a team in silos keep looking into, okay, how can I optimize RAN network? Maybe the RAN network is not talking to the core network, or even core network is not talking to the transport network. So it's always looked in silos. So that's one of the fundamental challenge, like where it is kind of evolving in 5G, where it comes in a holistic view to address the analytics and optimization.
Yeah. So if I go to the next slide, we draw a different picture here, which is when we move to network analytics on a 5G network, we're going to be looking at a different stack from an analytics perspective and from an automation perspective. you know, because these two now need to work directly in tandem and ideally without putting a human operator into the loop. I think initially operators will do that as they build trust, as Tilly mentioned earlier. But, you know, I think once there's trust built, you know, you can let the network kind of drive itself. And again, Naresh, you want to comment on it? Then maybe Andrew or Tilly, you might have some thoughts on this as well.
Yeah, absolutely. I think, you know, now from your earlier slides, now 3GPP has mandated a specific standard network data analytics function as part of the 5G SA architecture. So that being said, it's part of the call flow. So it's basically you're talking about orchestration. Dynamically, you're able to shrink and grow your network, or maybe you're able to manage the subscriber expectation, the QoEs. So obviously there is an expectation. It needs to be an intelligently driven, not a heuristic approach. Like I cannot just simply say, okay, if my CPU goes about like 70%, 80%, go spin up another control function. That's not the way it works anymore. So it has to be dynamically, you know, built a machine learning model, and basically you would like to understand, predict the network behavior, subscriber behavior, marry the subscriber behavior to the network topology, and maybe marry the network anomalies back to the subscriber, right? I think that's very important. So that's one of the fundamental reason why AI/ML will be an instrumental piece of 5G networks.
Andrew, you have anything to add to that?
Yes, I mean, this is very much in line with what we were, I was talking about before, where the analytics is baked in. So not only is it used by the other, by the signaling flow, by the core network functions, but by also available for all of the surround functions, for the operations administration and management, for the management data analytics services, orchestration, and others. And this it's simply going to be necessary in order to scale up to the kind of complexity and customization that the consumer, I don't mean the enterprise consumer that's going to utilize and pay for these services, they're going to want to be able to consume these services in complex ways, and it's going to change over time. And I don't just mean slowly over time, it change throughout the day, through the course of the week, as their operations need. Just like the enterprise, we're all used to being able to customize a lot of what we're consuming from digital service providers and other environments. There's no reason that the enterprise shouldn't be enabled to do this for their communication services, and that's really the promise that 5G holds, and it's enabled and delivered through analytics and automation.
All right. I'm going to pop to the next slide here. Let me just hit this. Yeah. So the 3GPP has gone through the trouble of standardizing network analytics in 5G. So somebody at the 3GPP must have felt that was important. I think what drives it is really what Tilly said in her presentation is, with 5G, we're looking at a far more diverse multi-vendor ecosystem, right? So on the left-hand side of the slide, I've listed all the different categories of vendors that'll play in the 5G ecosystem. And you know, you're trying to put together all those pieces and tie analytics from the RAN, from the core, you know, into things like service assurance and service orchestration, and doing all of that to kind of drive these underlying network automation mechanisms. It seems like if you did not apply a standard approach, you'd end up with a problem. But I'm going to let Tilly, Andrew, Naresh, you guys can riff on this here, I think elaborate a bit.
The only thing I would add, Stephen, is just, you know, yes, there's the multi-vendor best of breed angle to all of this that we've kind of already touched upon. I think there's also this, my network is no longer going to be one vanilla big network. I'm going to need to be able to do all of this on a per slice basis or a per service basis, and that's going to be different for all my, you know, for different enterprise customers. And I think, you know, the idea that operators will not be able to handle the SLAs and to handle the performance once we get to that level of complexity is also worth bearing in mind. So there's the best in breed side, and then there's that angle as well. And it may be that having these sorts of standards, or certainly having the insights from the analytics, and it may be that we can, you know, we'll see operational efficiencies, but I think we will. The question is, will it also enable some kind of service differentiation as well? Or will it enable operators to accelerate, as Naresh was talking about, their development and launch of new services? So that's the question mark for me, is how much we'll see the benefits on the revenue side of things as well as the operational side. But that per slice or per service basis is probably another important part of this picture to capture.
Right. Andrew, Naresh, you want to jump in? Andrew, go ahead, Andrew.
Well, I think that, I mean, it's really kind of amazing that I can kind of get off an airplane in over 100 countries and turn this device on, and it just works. And that's kind of the benefit that we get from standards. And that's where I see this going for this enterprise application use, where right now, beyond just the basic connectivity, everything else to integrate an enterprise application to the communication service provider is very customized, very specialized. And by getting to standard interfaces, that becomes much easier. It's easier for the mobile operator and it's easier for the enterprise. So that's part of what's necessary to drive the adoption. In addition, the enterprises that are going to be able to use this, they operate in a lot of different countries. And because of the regulatory regime, every country has their own operator. So they need to be able to connect in each of those different countries and get this information and operate successfully. That's really only going to be possible through standardization, so that there's a common understanding not only of how to connect, but what the information needs and what information is available. If it's all bespoke, it's probably too difficult for all but the very largest, most sophisticated companies, both on the mobile operator side and on the enterprise side, to use. And I think this has the potential to reach down much deeper into the economies, into the enterprises that can take advantage of it and really build innovative uses, whether it's in retail, in Industry 4.0 and factory automation. I'm personally looking forward to like venue, fan experience types of things that are going to come out that I may not even be able to imagine, but I'll appreciate when I use them.
Naresh, anything you'd like to?
No, I think those are good. So we can move. Yeah.
Yeah. Okay.
I think I don't want to beat the bush.
No. Okay. So I think, Andrew, I think I was going to ask you maybe to kind of just touch on the benefits again for analytic standardization from different perspectives here, and maybe I'll let you kind of talk through this here, and then we can discuss.
And I think that it's really to build the environment, the ecosystem of all of the capabilities that can be utilized and consumed by industries in different verticals to enable that communication, leverage that communication, and connect to the mobile operator at all of these different levels. That's a really kind of key capability in my mind, and a key differentiator is the enterprise can has the application level communication with the device that they're connected with in an industry, a retail, an IoT environment. So they can ask the device, hey, check your GPS and where are you? But the operator can give them much more information about it. Where is it in the network? What's the environment of that network? How often has it been communicating? What's its power status? What's its retrans status? Does it look like it's having a problem or not? Is it communicating with places that it shouldn't be, that you can't see? So by having the standardization and having the ability for multiple parties, multiple software vendors to come in and build these kinds of applications that can consume this data and understand how it's applied in different verticals, it really is what's necessary to build that ecosystem. So that's the productization of the analytics. On the orchestration and automation side, it's allowing that higher degree of efficiency and speed that Tilly mentioned in the operators. That's important, and I think it's going to be part of what's achieved, but that's only half of the story. The other half of the story is the ability to go to market and connect with the enterprise and offer the enterprise the kinds of services, capabilities, and information that they want to use to really leverage up their capabilities as well in partnership with the mobile operator.
Naresh, anything you want to add to that?
Yeah, I mean, so Andrew summed it up well. But if you see currently, like operators actually focus too much on ingesting different data sources coming from different network vendors, like all the big vendors, right? For instance, like it could be Nokia, Ericsson's of the world. Like they are the one who's generating a lot of data today. But the key issue is, rather than driving a use case, it becomes more and more problematic to just ingest the data and actually identify like what you can use of those data. So that's one of the reason I think having a standard analytics function, it's basically becomes more and more appropriate for network functions to generate a certain set of data that where it can be readily ingestible and drive a use case. So the ultimatum is actually to get the use case faster. So that's the reason, one of the reason that analytic standards is very important for MNOs.
Yeah, and I think there's also the problem that sometimes you can't even get access to the data, or the semantics aren't always clear. Maybe there is a published spec, but then, well, when this counter says this number, what does that really mean? So I think I think there's great benefit in standardizing data types, data semantics, and then, like you said, aligning the data types and the analysis with specific use cases. So you kind of take this out of the realm of, everything's a custom job to, well, we know when we're running networks nowadays, the things that matter. So we'll build up a set of use cases, and in NWDAF's case, there's a set of analytics IDs that are kind of well understood, and those get utilized by the various functions who are interested in that type of analytics for a particular use case. And I think it makes it a little more tractable for the people that are trying to build 5G automation systems. I don't know, Tilly, is there anything else you want to add before we jump to the next slide? Or
no, I think that's right. Where we're hearing there's this huge challenge is where use cases interface, or where you're looking for something which spans, it's more than just a point solution. And that's where, we're hearing real challenge. And so to have something that can help you to kind of normalize across is, is potentially a big value to operators who are struggling to move from kind of, I've got a point solution which is delivering some value for me in AI and automation, to something which is really scaled and able to interface with other use cases to generate even more value.
Okay. So let's move ahead here to the next topic, which is, Andrew, maybe you could just give us a brief rundown on, how NWDAF fits into the 5G core. And again, kind of do this at a high level and quickly, because there's a lot of information about this available, I know, on the Guavus website, but it might help to put a little more of crisp understanding for the attendees here.
Sure. So this kind of illustrates what I refer to as the virtuous cycle in network operations, where as a mobile operator, you will have services defined through service automation that get deployed through an orchestration infrastructure. They'll get deployed out onto the network itself, onto the core, transport, and access parts of the network, and maybe with overlay, as shown here, SDN, overlay, and others. Once the services are accessed and used, the network elements themselves will produce measures, telemetry, and state information. And what the network data analytics function's defined to do is to be able to collect that information, process it, and turn it quickly into useful information, real-time operational intelligence. Now that information then can go back into the 5G core elements themselves and be utilized as they do their processing. It can go to the orchestration system. So the orchestration system can then make the business policy decisions based on the accurate real-time state. And it can go up to the operations, administration management, and the management data analytics services for them to make the decisions whether they're real-time, medium-term, or longer-term kind of strategic decisions, even out to the extent of network planning. So this is this virtuous cycle of being able to utilize this real-time operational intelligence as it's being generated off of the network itself.
Great. So that's a NWDAF thumbnail sketch there. Let's go to the heart of the discussion here. I think the next slide. Oops, we got jumping around here with this touchy mouse. So let's kind of cut to the heart of the matter here. So this webinar is about CloudScale 5G analytics, and what I'd like to do, maybe Naresh, Guy, you guys could lead this off and talk about the importance of doing 5G analytics at cloud scale and what that means. versus what's been done in the past, which is typically sort of a on-premise based approach. Why don't we talk through the virtues of that approach here? I don't know who wants to take it first, Naresh or Guy.
Yeah, sure. Yeah. So if you see today, right, I think from an NWDAF perspective, I think the two fundamental piece of it is one is the data collection, another one is the analyzer. So irrespective of the use case that what 3GPP has defined, I think our thought process here is like NWDAF will actually finally evolve into one unified analytics portfolio for most of the operators. Like, because today they all have a siloed kind of analytic solutions that it is either looking into RAN separately or core separately, like we mentioned earlier. But I think NWDAF will become a the centerpiece of the equation when it comes to driving the 5G connectivity calls, or even enterprise managing intelligent service assurance slices and things like that. So when it comes to the cloud operation, first of all, the first thing is the dynamic challenges of ingestion of data, right? I think whether you do it at the edge or you want to do transport it back to the region. So AWS actually helps in scaling and collecting those data sets, different type of data sets that is getting originated from different network functions. That's one of the most important aspect of it. So we have seen operators trying to deploy 5G, and some of the core data functions, like whether it could be UPF, can be sitting at the edge, and also some of the control functions can be sitting at the core region. So today NWDAF talks about a distributed network, and AWS is perfectly poised to provide that kind of a distributed architecture, because primarily that we do have an expertise in driving these kind of distributed architecture at scale. And most importantly, I think the data prep problem, right? I think you're ingesting so much of a variety of data sets, and you wanted to correlate the data, wrangle the data, and make it usable for you to drive a use case is something that where cloud helps you to solve it. And then explicitly, like we have seen data scientists build a miniature AI/ML model with their miniature data sets, but once they throw it out in production, the results goes haywire. So basically, with the help of AWS, you can dynamically scale the compute power, and also bring a lot of AWS native machine learning services that where you can readily make sure that some of the models that you're building as part of analytics will be really scalable and readily deployable in production. Guy, if you have anything to say?
Yeah, thanks, Naresh. My comment here will be that basically, as you can see from the diagram, we want to see how we can help our customers in terms of bringing the NWDAF Edge capability to the edge. And this is where we were working closely with the Guavus folks on deploying the NWDAF Edge on AWS Outpost. And AWS Outpost is essentially, if you think about it, just a physical rack, a hardware appliance, very similar to any other AWS rack in an AWS data center. So from the customer perspective, it's a seamless experience, right? They deploy an AWS rack completely that AWS are completely responsible for. They deploy it on their on-prem data center, close, for example, to the UPF. And then we can start, hosting those AWS and NWDAF capabilities like the collector and other elements as well to collect the data close to the network elements, right? So then we can do the pre-processing and discarding irrelevant packets and send only the relevant data to the central component in the region.
Exactly. Andrew, anything you want to elaborate on here in terms of flexibility, scale, extensibility?
Yeah, I think it's actually a really exciting time. I've had fortunately, I've been in this kind of telecom OSS operation space for hard to admit, but 30 years. And it's really amazing to see the kind of changes. Being at Guavus now and really being focused on how AI ML is created and can be deployed to telecom operators, being able to leverage these hyperscale connectivities that are available in these cloud environments and available from Amazon Web Services has really been phenomenal, because we know, for example, how to effectively define and build machine learning algorithms, but they need to be trained, and they need to be trained and periodically need to be retrained and adjusted when they're actually in deployment. That's a huge resource burden from a CPU, memory, and sometimes even storage I/O perspective. So being able to leverage these kinds of cloud capabilities where you can burst up and do things like model training, which we know how to do very effectively with ML model operations in centralized core data centers, and then push that knowledge out, that information out for the ML models to edge deployments where they can actually be scored, because that edge scoring is actually relatively inexpensive from a CPU memory perspective. We know how to do that very, very efficiently, and that's really effective. So this separation of edge and core functionalities, it's what Guavus has been doing for years. I can see this coming in the 3GPP specs, which is really exciting to me when the specs kind of line up with what we know is kind of the way things work in the real world. Sometimes they do, sometimes they don't. Really, it's really a superior time to be in this environment to leverage these capabilities and to be able to make that a reality and bring these technologies together across the kind of hyperscale world to the telecom world and enable it in 5G services and operations.
Okay, we got about 5 minutes before we're going to go to Q&A here. So got a couple more slides here. I'm just going to set this up briefly. So back in June, Guavus announced an NWDAF product called 5G IQ NWDAF. And at the same time, Guavus announced that that product would run on AWS. So what I'm going to do is ask Andrew to talk about that on this slide, and then I'm going to ask Guy and Naresh to talk about a little more what's going on under the hood here in the regional data center and the remote sites. So
this
go
is
ahead, Andrew.
A representation of how we're enabled to do that. We've divided up the NWDAF capability, the product that as Stephen mentioned, we call 5G IQ NWDAF. There's an edge module and a core module, and the core module is responsible for central storage, for model operations, for the 3GPP registration interface types of functions, and the edge module is responsible for data collection and local data scoring. Now, with this kind of flexibility that the pure NF environment and the AWS cloud environment allows for us, we can run the edge and the core module co-resident, if that makes sense. And we can take that edge module and push it out to really far remote sites where there are remote operations that are producing the data. Shown here, like examples for the UPF. That's one of the network functions that we expect to be generating a lot of this data. And it doesn't always make sense. We don't want to bring all of this data back to the core to be processed. It makes a lot more sense to do it remotely where it's generated. We can do it, and we can reduce the data size by doing that. And that reduces network transmission as well as storage and all kinds of requirements in the core. So being able to do that with this kind of flexibility, not only in a deployment scenario, but for even us, for our development environment, where we're confident that what we develop works across all of these platforms, provides a tremendous value.
So just quickly here, Guy or Naresh, we're going to drill down a little bit about what's going on in the AWS Regional Center, and also what's going to be happening out at the Edge module. You want to just briefly talk about that before we jump into the Q&A?
Yeah, absolutely. So as Andrew mentioned, what we were thinking about doing here is firstly deploying the Guavus NWDAF solution first in the AWS region, as you can see here in the picture. And essentially the solution is completely based on Kubernetes. We are hosting it on Amazon EKS. EKS stands for Elastic Kubernetes Service. So essentially the concept here was to see how we can architect the solution across multiple availability zones to make sure that we are fully highly available. We are also using other services such as DocumentDB, because we wanted to select a data store that will enable low latency in terms of storing the data and accessing the data. But we are also using Kinesis data stream, and the reason why we're using Kinesis data stream is because we wanted to stream the data from the edge to the AWS region, right? Because we want to cater for real-time use cases. So this is the central module. As you can see, obviously, the different components. As I mentioned, everything was deployed on the EKS stack as well, and it's architected across the multiple availability zones.
So out at the edge.
Absolutely. So in the edge, we were working with the Guavus folks, and the idea is to see what we can, what components are critical here, whether it will be the data collection manager, SQL stream containers, but also the prediction job. So we wanted to host on Outpost the prediction capability. So we will train the prediction model on the AWS region, but we will host the actual inference for those low latency use case for the prediction endpoint on Outpost. So that was the key here. We also use a load balancer, so the traffic is basically coming in, and one of the advantages here in the 5G architecture, everything is REST-based, HTTP2. So we just receive the traffic directly from the different network elements that you can see on the left side.
Great. Well, thanks for the quick run through there. So we've got time here for some Q&A, and we've had some questions rolling in.
Maybe I just want to conclude a key point on that architecture.
Sure, go ahead. Yeah, go ahead. Yes.
Yeah, I mean, so the bottom line, the summary is, like, if you see from a spec perspective, right, like what has been defined in the 3GPP spec, they have not clearly called out how NWDAF actually, need to work hand in hand with respect to when it comes to edge and the core. Like, they have kind of defined, okay, it can run at the edge, it can run at the core. When I say core, it's at the central location. But I think what we have done here is, like, we have gone step ahead and we have defined how a typical 5G SA architecture will be deployed by an operator, like what can be done at the edge and what can go at the region. So keeping that in mind, like, we have actually defined how the NWDAF use cases will actually fit in with respect to edge versus the core. So I think that's a key aspect of it. Though 3GPP talks about the 10 release 16 use case, another additional 2 use case on release 17, but I think the options for northbound integration with many other network functions and defining other analytics is the key here, right? I think that's where we are preparing and gearing up from an architecture perspective. So tomorrow, if you're bringing additional use cases outside the boundaries of 3GPP, it should be a cakewalk. So that's one of the main, the thought process behind this architecture, that how you would be able to integrate this.
Right. Okay. So from a Q&A perspective, go ahead.
The one thing I would add to that is what I see for these analytics IDs and the way the network data analytics function is going to be used is what's in the 3GPP specs, release 16, release 17. This is just a starting point. There's been a lot of analytics IDs even added from release 16 to release 17. I expect there's going to be more. And that's actually one of the things that we're providing is the ability to add additional data sources to an NWDAF, because I don't think that 3GPP is going to think of everything up front. I don't think Guavus is going to think of everything up front. And the ability to add additional analytics, whether it's the MNO's own ML, so that they can incrementally adjust it, or we want to be able to allow the mobile operator to even add their own analytics IDs, so that if they're out ahead of the standards and able to provide enterprise services or operational automation that uses analytics IDs that haven't been standardized yet, they have a way to do it.
Okay, let's jump to some questions, because we've had some questions come in here, and I'm going to just rattle off some answers here. So there's one question is NWDAF, will it work in non-standalone networks? In other words, operating off of 4G core? The answer is no. NWDAF is a 5G standalone function. So it will not run in a non-standalone core. There was also a question, does each...
I'll add to that. I mean, NWDAF won't, because it's defined as a 5G service-based interface, but there are plenty of analytics that can work in against a 4G core, and Guavus has other products that serve that. I think your answer technically is correct, Stephen, that there is no NWDAF in 4G because there's no 4G core networks functions, core network services that would use it, but the types of insights are available, but they're in that older model that Tilly talked about, where they are the surround model.
So it was tied to a second question was, does each core vendor have a 3GPP defined API to talk to NWDAF? And that's kind of where the rubber meets the road on this thing. I'm just going to quickly jump in. All the network functions in the core that need to get information from NWDAF, there's a whole set of APIs defined for that in the 5G service-based architecture. We can't get into that, but that's kind of why it's a 5G standalone thing, because that's where all the APIs have been developed.
And not just the APIs for the analytics consumers, but the APIs for the raw data. There's a number of APIs defined in that 5G service-based interface that provides the data that the NWDAF utilizes as the foundation for some of those analytics processing. Many of them, most of them.
So there's just some sort of a simple question here, which was, does Guavus have an NWDAF product? Yes, I hope that's apparent. And will it run kind of in an on-premise, private data center method of operation? The answer to that just quickly is absolutely. But the interesting question that came in here was, well, when would I want to run NWDAF in the cloud versus when would I want to run it on-premise? And I'm going to kind of toss that, Andrew, to you and Naresh to kick around.
When in the cloud and when on-prem? That's a good question. I see a lot of different models yet. Most of the models where the service provider, the mobile operator is running on-prem is a significant concern and consideration for security operations and regulatory compliance. But I see opportunities even for those operators to be able to leverage the cloud for business continuity services in disaster situations, as well as for load and cloud burst situations. That's really one of the big advantages of the kind of pure functional virtualization that's been defined for 5G. So it's really, I mean, there's some technical considerations, but as Guy mentioned, the NWDAF is built in a fully containerized construction. So we're running it under containers in the Amazon cloud. It can run on containers in a local on-prem cloud, and they can be in communication as well, should that be effective for the service provider.
You also got a question about, sorry, go ahead. Sorry.
I was going to ask if any Naresh or Guy or anyone had anything to add to that.
Just a quick comment from my side. So exactly to the point that Andrew mentioned, what we are also envisioning is essentially we have a service coming up which is called EKS Anywhere. And EKS Anywhere will give the customers the ability to deploy those EKS clusters in their on-prem environment, for example, or on the edge. For customers who, for example, have already deployed the 5G core on-prem, they want to bring the NWDAF capability to the edge on-prem. They don't want to use Outpost, or for example. So we see multiple models, right? Whether it will be greenfield, like Dish or Swisscom, for example, where they build their 5G network on AWS, but it can also be a deployment on an existing 5G core which runs on-prem.
Interesting question came in about the relationship between NWDAF and the Open RAN Intelligent Controller, which has an analytics capability, a real-time and a non-real-time analytics capability. I mean, there's a couple of questions here, but maybe people could talk about the difference between the two and the relationship between the two. So I think that's essentially what the questioner is getting at.
Well, I'll take a first cut at it. There's actually multiple domains where analytics are going to be done. The NWDAF is defined for the 5G core, and as we look ahead and what's coming in release 17 3GPP specification, it looks like we'll be able to provide analytics for the data network and the application functions as well out of NWDAF, and that's very effective. They're very tightly related. The radio network itself has, even in the radio intelligent controller, there's two levels of control. There's real-time and near real-time. The real-time control is going to live in the radio. That's microsecond kind of responses for what's going on in the radio packet scheduling, and that needs to be down in the radio infrastructure at that kind of level of latency. Then there's near real-time. and I see opportunities for information to be derived from that near real-time RIC infrastructure and possibly consumed for it. It hasn't been defined now, but I can kind of see the shapes for some of that, where it might be valuable for the radio network to have some application awareness, which is what this would give it, in terms of how, not only how are the packets being delivered, but how is it being experienced by the user, whether it's a device or a human, and that really depends on what the application is. So that's where the application awareness comes into play, and to be able to take that into consideration to do some maybe traffic shaping or prioritization in order to make the best balance possible to meet all of those mixed SLAs that are being delivered over the radio network.
Yeah, well, from a 3GPP spec perspective, I think they stop explicitly, demarking what can ORAN is. Basically, RIC comes as part of ORAN and NWDAF comes part of 3GPP, and basically they have clearly defined what can be done. Some of the use cases can as part of NWDAF, right? For instance, even if you take an example, like let's say you take a UE load prediction. So the simplistic use case here is you identify and predict what will be the load on the UE, right? I think that like basically it will talk to a bunch of network functions in the core, and then basically it defines that use case. But what is interesting is you take that output northbound, and then basically you tie it back to REC, and then REC is making some policy changes in terms of whether it could be the self-optimized network, changing the radio towers, or forcing some of the congested subscribers to a different network tower. So that's a golden use case, right? I think where 3GPP has not defined it, but I think this is where I think collaboratively with some of the operators and with ISPs, that we should be able to define such end-to-end use case to actually visualize the benefits of the 5G analytics as against the 4G, where it was always looked in silos.
We got an interesting question here about trust, which is compare and contrast the data that NWDAF is going to collect, which has been standardized in terms of the data types and formats and semantics, versus data that just flows from kind of probes that you plug into the network, which some people may not necessarily trust that data. So is that another aspect of NWDAF to kind of build more trust into the data that's being sourced and ingested and analyzed? I don't know, Naresh, you want to take a shot at that? Or
yeah, sure. I think, without stepping outside the boundary here, right? I think the network function is being standardized to communicate in certain way. Like, for example, a UPF talking to AMF or AUSF, right? There is a certain way that it talks to. So basically, the protocol has already been defined, and there is a standard messaging, call flow messaging is being defined. So it's basically the trust is already established for you to make a successful end-to-end 5G call. So likewise, when you talk about the service assurances in terms of slicing, like for instance, our engagements with certain operators, they talk about creating thousands of network slices. How do you manage these thousands of network slices without having an intelligence built to it, right? I think that's where NWDAF comes into play, and basically NWDAF will define based on the standard network functions that the communication will happen. But anything beyond the standard, part of the call flow that you're trying to do, so that's where I think the trust question still comes up. Okay, can I trust the KPIs? But NWDAF itself is not generating new KPIs. It's defining how you need to intelligently manage your slices, how you need to intelligently manage your network based on certain definition of use cases. But can NWDAF ingest those different KPIs and formulate that into more of a meaningful use case? That's really left to the operator to define and basically create a collaborative use cases as part of that.
Okay. Tilly, do you have anything you wanted to add here? I think we're going to run up to the end here. We're getting about 5 minutes over.
I know we're over time, so I won't add too much. I think Naresh is right on that question of trust, and the other big part of it, I think, is just ensuring it's not a black box solution. Ensuring that there is that explainability and transparency with why a network is performing a certain way. So that's the only thing I would add there. But yeah, I think it's been a really great discussion.
You can reach out to the folks at Guavus if you're looking for more information, and to the folks at AWS as well. So I think with that, I'd like to thank our speakers. I'd like to thank Tilly. I'd like to thank Naresh and Guy and Andrew. I think this is a very interesting topic, and hopefully we'll get to do something like this again in the not too distant future. Thank you.